Hello friends, this is Durga from IT Varsity, a one-stop shop to learn all the technologies. So today we will be starting a new training. Starting from today, it will take around 6 to 7 weeks. I'll be streaming all the videos as backup for the live audience. You will see the video, but you will not be able to get the answers through chat or anything. Just bear with me. Okay, so let me launch WebEx, and then we'll take it from there. Let me mute everyone. Mute on entry and exit tone. Okay, so I hope people on WebEx can hear me, and also I'm sharing the screen. Please confirm that you can hear me and see my screen. If you have any issues, let me know. Okay, thank you. So let me start the recording here. And everyone on WebEx, please go on to mute. Okay. Okay, so please go on to mute unless you want to ask some question. So this is kind of a hybrid approach. There are quite a bit of audience in the room, and it's on loudspeaker, so it can be irritating. So just make sure you mute yourself. Only when you want to ask the question, you can unmute and you can ask the question. Okay, so let's get started. We'll start with the big data introduction. Let me open the presentation, and then we'll take it from there. Today I will try to cover the introduction part of it, and by the end of the session I will tell what you are supposed to do by tomorrow, so that we don't waste time in setting up environment tomorrow. You can try setting up environment on your own, and if there are any issues, we can take up before starting the class tomorrow. Okay, only this time you have to spend a good amount of time before you come back to tomorrow's class. After that, you don't have to. Most of the content will be self-contained within the session. Okay, so I'm. So we'll start with big data introduction, and what all different technologies we have in big data and what is the role of each of them. I will go through the presentation, and also I will try to map the skills, the technologies that we are discussing today on the cluster, what all we have. I will try to explain the relevance of each of the technology and what all are set up on the lab I will showcase. Okay. So let me take it to the full screen. If you think about enterprise applications, the enterprise applications are typically operational and decision support. So when I say operational, it could be transactional, it could be not so transactional. So example for transactional is bank applications. You credit from one account and debit to another account, which means that if you think from the database perspective, it has to do a lot of operations as a unit, and either it has to commit all the operations as a unit or it has to roll back. It should not leave as in inconsistent state, right? That is called as transactional. Whoever is not speaking, can you go on to mute? Yeah. Okay, so that is transactional, and RDBMS came into picture for transactional based systems. Boyce Codd actually wrote a white paper with the 12 CORDS rules, which a transactional based system should have. And from there, RDBMS has evolved. Oracle, Informix, Sybase, SQL Server, DB2. These are all RDBMSs implementing those Boy Scouts rules. Okay. If you think from enterprise perspective, probably 30 to 40% might be transactional in nature. Rest of them need not be transactional in nature. For example, if you take IRCTC, right? Only when you actually buy a ticket, it's a transaction. When you try to search, it need not be a transaction. You give Hyderabad as the source and Mumbai as the destination. It's just about searching the existing trains and giving the results, whatever is available, right? That is not transactional in nature. So we don't need to implement using RDBMS. Now we have many other databases which we can use to get those results, which will offload RDBMS significantly, and our applications will be scalable. That's why IRCTC is now working, at least compared to 4 or 5 years back. It was never operational, right? Because they have offloaded a lot of non-transactional use cases out of RDBMS. Only when you make the payment, it might go through RDBMS database. Otherwise, it need not go through RDBMS database. So that is operational. It can be transactional. It can be purely operational. You just give a request and get the response as quickly as possible without any transactions involved in it. And then traditionally, if you think from enterprise perspective, take a case of retail client, okay, where there are a number of stores for them, and they want to see how each store is performing, okay, so that they identify troubleshoot where the issue is, why a particular store is not performing well, and all those things. These reports actually drive the decisions of the executive management. That's what decision support means. Typically, we run reports out of the transactional data to compare and contrast, see the trends of the business, etc. Okay, traditionally, most of the applications are categorized as operational or decision support, and then there are some integration projects using TIBCO and all, but they complement these things. You cannot visualize as a high level application. Okay, sometimes for decision support you might have to integrate the data, and for that you might have to use some enterprise application integration tools. Or if you want interoperability between multiple projects between different clients, that's where enterprise application integration comes into picture. That's secondary, but primarily most of the applications are categorized as operational, which runs your business, and decision support, which will let executive management to take certain decisions. With the success of social networking, Google, etc., the paradigm have shifted for the applications also. So these days we are also seeing a new wave of applications, which is customer analytics. Okay, typically customer analytics is similar to decision support, but the major difference between customer analytics and decision support is, so if you think about decision support, typically we use BI tools such as Cognos, uh, business objects, MicroStrategy, etc., and then build a data warehouse behind them to run the reports. If you think about the number of users for these BI tools, they will be handful. Typically, the executive management or the PAs of executive managers or analysts working reporting to executive managers, they are the ones who will actually use these BI tools. Okay, so it's, even if you take the example of world's largest enterprise, probably 1,000 or 2,000 people will be there to see the reports, not more than that. So decision support, the user base is small. Whereas customer analytics, can you guess an example where customer analytics comes into picture? Any example?
Millions.
User base will be millions, but my question is, guess one use case which categorizes under customer analytics.
Walmart retail sector where they want to expand a product line or production.
Not exactly. So I will tell a few examples. For a company like Walmart or Flipkart, we are customers, right? And we end up spending a lot of money at a particular company like Flipkart or Amazon, right? And we are all customers, and we want to see in which categories we are spending money, whether we are wasting our money. Because over a period of 1 year, let's say take the example of credit card. Okay, there are people who spend 60,000, 70,000 rupees per month on credit card, which means over a period of year almost 10 lakhs. So if the credit card company can give a report where your 10 lakhs are being spent, I can see that report at the end of the year and see whether I can uh, use my money more efficiently. Okay, that is customer analytics. I want to know in which categories I am spending money. Am I spending on holidays and vacations? Am I spending on coffee and other food? Or am I spending on clothes, etc.? So that will give some idea to me. If you are familiar with Mint.com, Mint.com is US based company which is acquired by Intuit. Intuit is the very famous US company where they have products like TurboTax and all those things which automate the tax filings, etc. So that Mint, you can register all your credit cards with them, and they get data from all the credit cards and actually give a report to you where you are spending money, and you can actually set thresholds. If I'm spending money more than this much in a given month on a particular category, send me an alert. If we configure that, it will start sending alerts. So this is all customer analytics where our which can drive our decisions. Okay. Now it will, even though it does not impact the bottom line of the company directly, it can improve the loyalty of the customers towards the organizations. And now technology is available. Most of the people are actually spending time on that. Okay, customer analytics is another set of products that are coming in. YouTube have it. I am one of the content publishers on YouTube, and I can see my daily report how much traffic I am getting. YouTube is one classic example for customer analytics. Think about any affiliate based businesses. There can be hundreds and thousands of affiliates for a company. For example, Flipkart, there might be too many vendors. We are one type of customers who are buying products. At the same time, there will be sellers in Flipkart, Amazon, etc. Who can, it can be hundreds of thousands of them, and they should get their own report how their businesses are performing. So that is customer analytics. And so now we have to visualize using that third dimension also when it comes to enterprise operational, which is core business, decision support, where which drive the decisions of the executive management, and the customer analytics, which will give insights to the customers. When it comes to complexity, decision support systems are far more complicated compared to customer analytics, but decision support systems cannot scale. Hundreds and thousands of users cannot use decision support system. Whereas customer analytics, it will be simple report, but the challenge is scalability. You have to design such a way that it is scalable. Okay. So this is how this is the architecture of the enterprise application, where you have, this is monolith architecture. You have a database. All your modules in your application will go to one database, probably in different schemas, and then you have application servers in the middle, and typically users access through browser. This is the typical entire architecture. The layers can be many in the middle for application servers. Okay. The reason why I'm explaining this is you need to understand these things to uh, to judge whether big data will be able to solve your problem or not. Okay, you cannot start using big data just because it is hot. There are certain scenarios where it will fit. There are certain scenarios where it will not fit. So we need to understand that. To understand where it will fit, you need to understand the challenge of the existing systems. Okay, so one challenge I have already covered. One is when it comes to customer analytics, none of the traditional applications or technologies will not work. You have to use big data technologies only for customer analytics. We will come back to that again. That is the reason why I'm covering these things. Okay, today's session will be pretty much theoretical and dry, but for people like for senior people, it might make some sense. For freshers, it might be a little bit challenging to digest all these things, but for senior people, it will make some sense. Okay, and if you think about what's happening around, as of today when it comes to traditional applications such as operational and decision support. Standardization and consolidation of hardware to cut down the costs. That's where cloud is coming to picture. It helps us. Cloud and virtualization takes care of that. And as part of this standardization, typically storage is physically separated from servers and connected with high-speed fiber optics. So earlier when we start 12, 13 years back, the database servers used to have CPU, memory, storage, everything on one machine. And there could be multiple hard disks on the same machine. But even if one hard disk failed, there used to be outage on the database. Okay, that was 12, 13 years back when I started writing my first application against Oracle database. If there is a failure on the hard disk, there is outage. You have to restore, recover, and then bring up the database. Now, because of the standardization, your storage is network mounted. CPU and memory will coexist. And on that, you will have only your database binaries. You will not have data on the server. Instead, data will be network mounted. So the database engine is smart enough to do the network I/O and get the data whenever you request for it. So the advantage of having network mounted storage is you can leverage concepts like RAID, okay, wherein even if some of the hard disks fail within the storage layer, still it is transparent to you. You don't need to get outage for your application. If you configure with RAID mirroring, even if half of the hard disks are gone, your application will be up and running without any issues. Your database will be up and running without any issues. So it is pretty transparent. So now, even before getting into big data, 5-6 years back, when RAID is being implemented in almost all the storage layers, and when it is embraced by database technologies such as Oracle and all, we don't need outage for hard disk failures.
What was that? RAID.
RAID, RAID. RAID configuration. It's storage technology. Okay, so those are the advantages of doing this standardization and consolidation of hardware. It not only cut down the costs, but also it will reduce the probability of the outage. Okay, and this is how it look like. You have the storage cluster on the right, where those small rectangles in that are nothing but hard disks. And then you have database servers. So each database server will have its own CPU and memory. Okay, and then there will be at least 2 network switches. Typically in production, there will be more than 2. One network switch is just to communicate between storage and these database servers. And the other network switch is for the intercommunication between the database servers. Okay, typically these are all connected using fiber optics. Now, Oracle is the most popular database, so I'm trying to explain the same thing from Oracle perspective. So what we do, we actually provision storage. We storage rack and put as many hard disks as it can hold. And then you create a logical volume out of it and mount that logical volume onto the database servers through network switch. So one thing you need to keep in mind here is each database server will have a consistent view of the storage layer. Okay, so that's how the technology is built. It will always have the consistent view. If one database server is viewing in one format, other database server also has to view exactly like that. It should not change. If it is inconsistent, then your projects will start running into issues. If database servers, when they are configured with rack, this is called as rack setup, real application cluster. If you when you set up like this, if one database server is viewing data as one point in time, and if other database server is viewing data as of some other point in time, then your applications will start breaking. They have to get the consistent view. This point is very, very important to remember, even if you don't understand, because this is the major difference between distributed systems and traditional RDBMSs. In RDBMS, each database server need to have the consistent view of the storage which it is using. In this case, it is only using that small vertical rectangle which will be mounted onto the all database servers.
So same view means in terms of configuration or in terms of
no data should be same. So if If one node is seeing 100 records in a table, other two nodes also have to see exactly the same 100 records. Okay. If one is seeing 100 and other is seeing 101, then there is issue. So there is something called global enqueues, which will take care of those things. So this is the monolith architecture, which I have explained, and now I replace the database server with what I have explained just now. So as of current scenario, the traditional RDBMSs are typically clustered. It is called as rack in Oracle. The advantage of using cluster is high availability. So even if one of the database server goes down, still there are two database servers. So for example, if you go back to this picture, sorry, that's wrong button. If you go back to this picture, if this database node is down, my mouse is not showing up there. It is not showing up.
You can point here.
No, it's okay. Yeah, now I got it. No, not. No, yeah, it's fine. I will show. Okay, so here, let's say this node is down. Let's say motherboard on that server is down, is broken, which means we have to bring that node down. But still, we have two other database servers which are actually having the consistent view of the underlying data. So your application will not have much impact. Probably some of the transactions which are in pipe will be broken and rolled back, but your data will be intact. So zero downtime. Your applications will be highly available.
What about the data stored in the broken?
No, nothing will be stored over there. Everything will be stored in the storage layer only. So if you see here, your always data will be, once it is committed, data will be stored in this layer only. In this layer.
Storage.
Yeah, in the storage layer. Here also you will have some storage, but the storage will be used only for the software of your database. Your data will not be stored over there. Logs, software, etc. Actual data will be network mounted. Okay, so that is about high availability. Fault tolerance, again, it's almost same. Load balancing. So if you have 100 users, 1,000 users on a single node database able to access simultaneously, you can add more nodes and you can scale up. But only issue is scalability might not be linear. Load balancing and scalable are little bit related. So when it comes to load balancing, you can do it in different. There are different types of load balancing when it comes to database level. We don't need to get into too many details over there. But the last point is very important: scalability. So now if I have three nodes, three database servers like this, right? If one database server is able to support 1,000 users, definitely if you have three servers, that means you have triple the capacity. It should be able to support more than 1,000. Ideally, it should support 3,000 users. But when you actually go to the multi-node environment or multi-node database, because of the global enqueues, which I have explained earlier, to keep the consistent state of the data across all the databases, there is significant overhead. Okay, even though it scales up, it does not scale up linearly. One reason is global enqueues. Second reason is when it comes to transactional based systems, they actually do the IO at block level. They don't read at one record at a time. They actually read the entire block if it has to get one record from a block. And that all adds up to the overhead. Main thing you need to remember is in traditional RDBMSs, by adding capacity like this, the scalability will not be linear. One reason is global enqueues. Second reason is this integrity constraints and all those things. There are several reasons. You don't need to get into too many details at this time. If you are interested, you can explore it. or we can take it offline, but keep that in mind. It will not scale linearly. That point is important. It depends upon the complexity of the application, how much it can scale. So even I have worked quite extensively on Oracle. After a while, adding nodes is very expensive. Okay, and your cost will go up significantly. And then after a while, it will not scale up anymore. At some point, it will actually scale down also because of this overhead. So it is called as law of diminishing returns. So the scalability follows the law of diminishing returns, which means if one node is supporting 1000, probably two nodes might support 1500 or 1600. Three nodes might support probably 2000. Four nodes might support only 2200. And after fifth node, it might go down. That is called as law of diminishing returns. If you look at the graph, it will look like this. Okay. So on the x-axis and y-axis, you have the number of nodes here, and then the number of users that are trying to use. Okay. A number of nodes on the x-axis and number of users that are trying to use on the y-axis.
As nodes increase, load.
The overhead will become significant, and eventually it will not scale up anymore, because to maintain that consistent view across all the nodes, the overhead is very significant as more and more nodes are added.
If one node supports 1000, it's not 5 nodes support 5000. But
It
because
will,
of the to maintain the consistency.
yes,
That's overhead.
yeah. Okay, and it has common network storage, and it follows file abstraction. So earlier, 10 years back, when CPU, storage, memory, everything is co-located, a database file on the server can be at max the size of the server, the one hard disk of that server. For example, if I have two hard disks on my laptop, which is of 512 GB, okay, my hard disk can hold a file not more than 512 GB. That is the maximum size of the file which I can hold on my laptop. Unless I create a pool out of the two hard disks and try to use 1 terabyte by having a logical abstraction, I will not be able to store 1 terabyte size file on my hard disk. So file abstraction is that file can be of any size up to the overall capacity of the storage layer. If your storage layer have 5 petabytes, and if you create a pool of this 5 petabytes and mount onto a machine, your file can go up to 5 petabytes. Okay, that is called as file abstraction. That is already included as part of this architecture, because here if you see, we have multiple hard disks and we have created a logical view of some portion of the storage, and we are mounting this one. This can be larger than any of these hard drives. Okay, if anyone is familiar with Oracle, you guys will understand very easily. Earlier, there used to be a limit on the database file size. Now they have increased it to 4 terabytes. Earlier it used to be some gigabytes. Now it can go up to 4 terabytes. Even it can even back up that 4 terabytes of file very quickly, because of this logical abstraction on top of physical storage. Okay, now almost all these applications follow similar NTR architecture. Not only when I talk about applications, I'm not talking about databases, but our web applications, e-commerce platforms, take anything, IRCTC, all typically follow this architecture of having multiple application servers in the middle, database server, and then clients using it. Okay, however, there are exceptions, legacy, mainframe-based applications which uses closed architecture. I'm not very good at that, so I don't know much about it. So from the bird's eye view perspective, this is what is happening. You have a bunch of storage servers, a bunch of servers which are designated as database. For databases, we typically use a lot more powerful servers than application servers. And then there are a bunch of servers that are categorized under application servers. Okay, now the challenges. What are the challenges of this? RDBMS is originally designed for operational and transactional using COTS rules. If you're familiar with COTS rules, he explain what is a transaction, how view should be. He give a lot, all those things. Okay, so they have included all those things as part of this database. And databases are not linearly scalable, which I have explained earlier. Very expensive. If you are familiar with Oracle license, you have to pay $5,000 per core per year. So if you have a very big database, and if you are using 16 cores to support that, just for the database, you have to pay $80,000 to Oracle. Okay, very, very expensive. Like that, if you think about large enterprises, they will have hundreds of databases and they're paying millions of dollars to Oracle every year for databases. Predefined schema, when I say predefined schema, if you think about create table command, what you do, you say create table, give column names, give data types, and if you want to enforce any constraints, define the constraints, create primary key constraints, create indexes, create foreign key constraints, all those things. So what does that mean? When you try to insert the record, insert is nothing but a command. It's an SQL command, and that command will be compiled into some program, and the SQL engine will actually compile that into something else. And at the operational level, if you get into the details about how the insert happens, as part of the insert, depending upon the constraints you have, depending upon the column names you have, depending upon the data types and precisions you have, it has to check for all those things. It has to validate for the record being inserted into the table for all those things, and then only it will be able to insert. Okay, when it comes to real-time applications, that makes sense because they will be dealing with individual records. For example, if I buy a product from Flipkart, my money has to be debited to them, and then from their product catalog, they have to reduce the number of products which I'm trying to buy, and then place the order in a new work processing state. Once it is shipped, it has to be updated, and eventually I will get the product. So for each order, probably they might be touching 5-6 tables, around 10-15 records. It's okay, means even within few milliseconds or few seconds, it can be done. It's not a big deal. But the same thing, if I want to use it for reporting purpose, take the example of a major retail store where there are so many stores across the country. If they have to get data from all those stores into some other database and try to report, we don't want to deal with individual records. Already the records are validated well enough on the source system. Our validation need not be that significant. And also at the time of loading, if for each and every record, if it is checking all these constraints, the data type, precision, etc., it will take enormous amount of time. That's why Oracle is a major failure when it comes to data warehousing applications. Okay, even though it is very successful in RDBMS, it was a major failure for data warehousing projects. That's why Teradata captured that market. And then there are many technologies like Redshift from Amazon, Greenplum, Vertica. All these guys actually grabbed the data warehousing and analytics market. Okay, if you know Redshift, if anyone have worked in Redshift, you will define primary key and foreign key, but they're all informational. It will not enforce. Okay, it's your responsibility to take care of data quality and all those things. Because it does not enforce, the data load is n number of times faster than Oracle, because it's not loading one record at a time. It is actually taking the file, doing minimal validation, and then it will try to directly load into the database with very few validations. So the load will be much faster. Here, as we are getting the data from the source system, as long as we have a technical specification well defined to integrate between source and target, it works without much issues. Okay, so doing that extensive validations is not that relevant as it is in the mission critical applications when it comes to analytics, data processing, etc. Okay, so even though predefined schema is good in transactional based applications, for batch and analytics, it is not good. Okay, so another disadvantage or challenge is data processing do not happen where data is stored. This is very important point you need to understand, and this is one of the major difference between all these are major differences between traditional databases and big data and other open source technologies which are trying to grab market in that area. So if we go back to the previous slide, I don't know how to erase this.
It is only.
Okay, so if you think about it, we have this this is the storage which we are using for our database, right? So let's say someone have written a query on a table to just get the count. For simplicity sake, there are no indexes on the table. What will happen? Let's say that the table is of size 1 GB or 10 GB. Okay, so 10 GB worth of data we are trying to pull. We are trying to get the count. What will happen when you issue the query? The query will go to the database engine. It will compile the query. It will do the network I/O, get this 10 GB worth of data over the network, get to that server, and then it will do the count. Okay, so the entire 10 GB worth of data has to travel over the network to get the count. That's why if you have worked on any Oracle projects, when you try to do the analysis, sometimes you just run select count of star on one particular condition, and it takes forever if the table is very large. If the column is not indexed, it will take very long time. It will not be very large table with when it compared to current standards. It could be just 4 or 5 GB worth of data. Okay, and when you run select count of star on the table where on a particular column which is not indexed, it will take few minutes to get the count. Sometimes it will fail also because it has to do all these things and get to the database server and then do the actual count. Okay, which is very inefficient. If we can do some processing at the storage layer, it is much better.
The time taken is to get the data in the pipeline.
In yeah,
Processing,
both.
both will take.
Yeah, because at the processing layer, it will be single threaded. Okay, it has to go through the entire 10 GB worth of data using one thread. That will take some time. The major time consuming task will be network I/O. You can use parallel hint to mitigate issue up to some extent. But if you are talking about terabytes of data, that parallel hint will not work because it has to use the same network switch. Network switch might become a contention. Okay, so that is another challenge. So data processing never happen where the data is stored. The processing happens in the database server level sometimes when you run the query. If if it is a Java project with J2E and all, if you have server side coding at the application layer level, some processing will happen, and then some processing happen will at the browser level. Client side validations and all probably might happen at the browser level, but never processing will happen at the storage level. This is a major disadvantage when it comes to analytics and data warehousing when we are dealing with huge amounts of data. Okay, this is another very important point which you need to keep in mind. You can stop me at any point in time and ask the question. Okay, so I explained this as part of the last class also, evolution of databases. We started with relational databases. Now we have so many: NoSQL, in-memory, search-based, batch processing. I forgot to mention EDW databases here, EDW and MPP. Let me correct this slide.
Share the slide.
Yeah, I will share. This is very important slide because you guys are all mostly application developers. So if you are trying to implement any project from scratch, you have to evaluate all these things and decide which technology will be good for your module, and then come up with a microservices approach. So we started with what is that? Monolith architecture. Now we are talking about modern applications needs to be polyglot. Different modules have to be built like microservices, and different modules might use different category of databases, not different databases. It can be different category of databases. One module can use NoSQL, one module can use relational database, another module can use such based databases. Okay, now we are getting into big data. So any questions so far? Now we will start understanding why big data is getting relevance and why what kind of problems it is trying to solve and where it does not fit well. We will see those things. So history started with Google search engine. What is the typical behavior of Google search engine? It crawls web pages, it indexes web pages, and when users try to search, it will return search results based upon the search. So they started with MySQL as a database. They went up to 2000 server setup. They have at some point they have 2000 MySQL databases to support their search engine. After 2000, it's completely unmanageable for them. They are not going anywhere. That's when they actually re-engineered the problem and they started implementing using their own technology. They have written this from the scratch. GFS stands for Google File System, which is nothing but a distributed file system. Then MapReduce or Google MapReduce, which is nothing but distributed processing engine, and Google Bigtable, which is nothing but a distributed index table. These three are developed in tandem, and they work. They complement each other very well. Especially GFS and Google MapReduce, they are part of one. I think one project. Okay, at least from Hadoop perspective, they are part of one project. I'm not sure about Google, but Hadoop perspective, distributed file system and distributed processing are one project. And then indexing, distributed indexed table is another project. So how it works? They crawl all the web pages, dump the data into GFS, most likely, and then run MapReduce, do the processing in the distributed model, and index and store it into a indexed table. Okay, that Google Bigtable is nothing but index where the key will be keyword people are trying to search, and value will be the search results. Okay, so these are the three technologies which they have implemented to bring the Google search engine up to the current level. And then they published the white papers on those three technologies. Let's get into the details about what they have implemented in that at a very high level. So distributed storage, they have storage in the distributed format. And fault tolerance, when it comes to fault tolerance, now, so for all these things, they start using commodity hardware. Okay, and they realize that separating the storage from the CPU and memory is not a good idea, especially if you want to do heavy volume batch processing. They have to be co-located. Okay, so what they have done, they use commodity hardware, and then they, instead of using these network based technologies and RAID, etc., they included fault tolerance as part of the storage mechanism itself. So they call it as replication. In that, we will see what that replication and all when we actually get into the actual technology. But for fault tolerance, in this, we don't use RAID. We use something called replication. It is part of the algorithm of storage. And then distributed computing, data locality. In this, code goes to data. So when I run a Hadoop command, Hadoop jar command or Spark submit job, Spark submit, I'll be doing on one node called gateway or client node. Okay, and when I run it, what will happen? It will try to copy the jar file which you submitted onto the nodes where the data is existing, and it will process data locally. Okay, so the advantage will be, instead of if you think about the 10 counting 10 GB worth of data, if you think here, whatever code that compile to get that count now is going to the nodes and doing the count over there. Okay, so instead of getting 10 GB worth of data, probably you might be copying a few megabytes of jar file onto each of the nodes. And not only that, you are not only eliminating the network layer, you also can achieve the distributed computing because multiple nodes can actually process the data and get you the count. To get the final count, again, there will be a coordinator process who will take care of it, but most of the processing will be done in the distributed fashion. Okay, we will see the example. That's where, if you want to understand how it works, you need to get into MapReduce and all those things. We will cover that a little bit later. The main advantage is data locality and scalability. It's almost linear. Nothing can be linear completely, but it is almost linear. For some of the use cases, such as filtering, applying row-level transformations, etc., it is completely linear. You just keep on adding the capacity, it can take any volume of data. But there are use cases such as sorting, ranking, etc. You might know the complexity of sorting and ranking. It cannot scale linearly, but you can achieve maximum level of scalability even for sorting and ranking use cases. But it can never be linear when it comes to sorting the data. Okay. And then low cost hardware, you can use any commodity hardware, and then low licensing costs. Now people are not actually using low cost hardware and licensing. Licensing is a issue, but when it comes to hardware, if you think about enterprise clients, now you need to understand what they have done last 10 years. In pursuit of standardizing their hardware, they actually built their data centers completely new. Okay, because to standardize the operational costs, to standardize the infrastructure and reduce the operational costs, they have decided to go with very powerful servers. You leverage virtualization, and then over a period of time, you will be in a situation where management costs will go down significantly. Operational costs will go down significantly. So for that reason, what they have done, for some of the companies where they used to have hundreds and thousands of servers on HP Unix, hundreds and thousands of them on Solaris, hundreds of thousands of them on IBM, what they have done, they choose one vendor and try to go with either IBM P series computers or HP supercomputers or Solaris supercomputers, and try to standardize their operational costs. Okay, for that purpose, and also from storage perspective, they have gone with EMC. For networking, they have got all fiber optic based switches. So they invested a lot of money not only in buying the hardware but also to rebuild their data centers. Okay, now if even if they want to explore big data project, if someone go and use commodity hardware, most likely uh, their infrastructure might not be able to support. And even though the hardware is cheaper, they cannot rebuild the data center again. It's out of question. That's why there is a lot of pushback from enterprises to embrace these technologies 3-4 years back. So that's why Spark, Cloudera, Hortonworks, all these vendors, they are trying to push Spark quite extensively because enterprises can invest on, or they already have expensive hardware, and Spark is memory driven. Some of the disadvantages of having network storage can be mitigated using Spark. So that's why they are pushing for high-end hardware. So 3-4 years back, we used to talk about 16 GB, 32 GB servers for production setup when it comes to Cloudera. Now, minimum is 128 GB. The server has to have 128 GB RAM. And they want to minimize the number of nodes in the cluster and have a lot more powerful servers and use technologies like Spark to process the data rather than using commodity hardware. So there is a little bit difference in the way tech companies are looking towards into it and the enterprises are looking towards it. Okay, tech companies, they are mostly startups and they cannot afford those high-end hardware and all those things. So they are going towards cloud, and enterprises, they want to leverage their existing hardware and build on top of it. That's where Spark is getting a lot of momentum. So that low-cost hardware is partially incorrect. Licensing costs, it's very cheap or free compared to Oracle. Unless you want to go with support and all, you don't need to pay anything for most of the softwares in big data. That is one of the main reason why big data is getting some traction, because licensing costs are significantly low.
So low cost hardware does not include hard disk.
It includes everything. It includes everything, but as I mentioned to you, when it comes to enterprises, hardware need not be low cost. When it comes to startups, they can have uh, commodity hardware. And 3 or 4 years back, I have read an article. Uh, Teradata, it used to cost, I'm not sure about today's cost, it used to cost $125,000 per year per Teradata, per 1 terabytes of data. Whereas with Hadoop, we can get it for $15,000 per terabyte. So it's almost 10x difference. Okay. Uh, because not only hardware, licensing, everything included. Okay, evolution of Hadoop ecosystem. So now we will talk about Hadoop ecosystem. We have seen what are the current trends, and we have get into big data ecosystem. Now we are getting into Hadoop. Okay, as I have mentioned to you earlier, Google is the main company which started the concept of big data, because the volume they are trying to process is phenomenal. It's huge. Okay, and then down the line, when after the success of other companies like LinkedIn, Facebook, etc., some people from Facebook, some people from Google, some people from Oracle, they pulled together and they started converting the white papers published by Google into a technology. And the person who initiated that process is Doug Cutting, and Hadoop is his son's toy name, elephant toy name. Okay, so they took this GFS white paper, Google MapReduce white paper, and Bigtable white paper, and then they have developed HDFS, Hadoop MapReduce, and HBase using Java. Okay, Google technologies are developed using C, C++, I guess, but Hadoop is mainly built using Java. Okay, and what are the use cases that can be addressed? ETL, we can do data processing through Hadoop ecosystem. We can do real-time reporting using technology such as HBase, but with limited capability. It will not be as robust as or as flexible as the traditional BI tools, but we can do minimalistic reporting. Batch reporting. So, for example, let's say you are all customers for Flipkart, and you want to get your something like a newsletter once in a month about your expenses. So they don't need to provide access to an interface to you. They just have to blast an email with a report which you might be interested in. Okay, and that happens with many companies. I worked for a major telecom company. There, every month they will send the report and their telephone bill, and it will have a call log. Okay, and these things, um, either you can get a link in your email ID which will have access to the PDF, or they can send it as an attachment. So this can be batch processed. You don't need to provide a interactive report for that. So that is called as batch reporting. You can do it very effectively with Hadoop. And then you can also implement operational but not transactional. Okay. When it comes to operational but not transactional, you can use tools like HBase, and you can implement. Facebook Messenger is implemented by HBase. Means the underlying database for Facebook Messenger is HBase.
Can you elaborate on the last point? Operational but not transaction.
So so there, let us take a few examples. What kind of applications can come under that? Your chart-based applications, recommendation engines, endorsement engines. Okay, so recommendation engine is the example which I have given as part of the last class. When you try to search for a product in Amazon, you will see all the recommended products. The underlying database which support that visualization for you, which will get you the response and provide the visualization for you. You don't need to use RDBMS databases. Amazon uses DynamoDB, which is a NoSQL database. In Hadoop ecosystem, we can use HBase for that.
And you talked about real-time reporting. Is it only limited real-time reporting, or
Yes,
you
it's
cannot do report up to a certain extent? You can do reporting, and then for complicated needs, you rely on some other
no,
tools?
no. So as I have mentioned to you earlier, when it comes to customer analytics, our reports will be simple, but the complexity is the scalability. So for those kind of scenarios, you can consider HBase. If you are familiar with Facebook, each individual will have a page, and if you click on the page, you can click on the likes, and you can see the trend about how many people are talking about, and also how many people are being added compared to the previous period. Those type of reports can be implemented using technologies like HBase, Cassandra, MongoDB as the underlying database. For visualization, you can use D3JS or something, connect to the underlying database and get the report out of it. So uh, there the complexity is scalability. For all these reports, even if you look into endorsements of LinkedIn, it's not a very complex report. But the challenge is there can be a number of users who will be hitting at the database at a given point in time, and all those users should get proper proper reports without any uh, downtime. The page should respond always. So in those scenarios, we can use NoSQL type of databases. Okay. Typically, when you think about scale, your reports will not be that complicated. So these are the tools: operational and real-time data integration. We can use HBase. For ETL, we can use any MapReduce based solution, or even MapReduce itself, Hive, Pig, Scoop, etc. You will understand those things a little bit later. I'm just trying to map the technologies to the use cases. For reporting, we can use Hive for batch reporting. Means when I say Hive, you. So again, I need to reiterate this. Most of these technologies, Hive, Pig, Scoop, etc., they are just a bunch of commands. Okay, especially Hive and Scoop, they are just a bunch of commands. Hive is nothing but SQL. Can you build an application using SQL? No, you cannot. You have to use some programming language, some framework to build an application. Even in this case, even though I say for reporting, batch reporting purpose, I can use Hive, there has to be a application built using Hive commands. That can be Java based application, that can be shell scripting based application, that can be Python based application, that can be any programming language which can access Hive and run Hive queries. So programming is the key. There is a misconception in the market. It's deliberately induced into the market just to exploit the hype. And most of the guys say that learn Hive and Scoop, you will become a big data expert. Okay, ideally, programming is the most important. If I have to build a team, I will identify the developers and train them in big data. Okay, learning Hive and Scoop, you can get it. Syntax and semantics, you can get it and learn easily. There might be some challenges, but it's not a big deal for a good programmer. I will get them trained and I will let them work on that. But unfortunately, because the decision makers are out of touch with the technology, they compare, for them Hive and Java are same. For some of the people, Hive and Java are same because they don't understand what it is at the decision management level, especially if they give up the technology long time back and just become people manager and enjoying the fruits because of the headcount. They don't need to explore the technology in depth, and they are the decision makers, unfortunately. Okay, so and also these training institutes like Edureka, Simply Learn, all those guys, they emphasize a lot on Hive and Scoop because that's the only thing their instructors can teach. Okay, so people are misled deliberately. Okay, so don't think that using Hive you can build a reporting layer. Hive is a database which can support your reporting, and you have to build application around it, even if you have to blast an email to people with a report. Okay, So then Impala and Presto is for ad hoc querying or ad hoc reporting. And then for analytics, we can either use MapReduce based APIs, or there are other frameworks also. There are many miscellaneous or complementary tools for administration purposes, which you need not worry much as a developer. Okay, these are all uh, primarily for administrators. For developers, you should not worry too much about these things, especially Cloudera Manager, Hotmark, Sambari. Uh, they are all um, cluster management tools. They are not developer tools. Okay. So now, what is the time now?
It's 340.
Yeah. So we still have 45 minutes. Uh, so now we are talking about data ingestion. So typically, your Hadoop-based system is a downstream application, and you have to get data from different sources. Okay. Let us understand. I'm talking about data integration, not just data ingestion. So if you break down data integration into multiple pieces, you have to do data ingestion, which means you just get the data from the source systems without much modifications and load into downstream databases, and then you do data processing on top of it, and then you can do data analysis or visualization. So for data ingestion, sources are typically relational databases, non-relational databases, streaming weblogs, and flat files. Okay, so there are different types of sources which we need to get data from into downstream applications. Forget about big data. Any downstream application, these are the things from which you need to get the data. And the things are, it could be a data warehouse appliance, it could be relational database, it could be HDFS, it could be anything. Okay. When it comes to data processing, these are the
Do we have any specifications regarding type of data,
type of data.
flat files, images?
Yeah, so flat files, it could be anything. Means you just need to develop APIs if nothing is available. So as of today, there are APIs for XML, there are APIs for JSON, JSON file format, there are APIs for CSV, tab delimited, and all those things.
Images.
Images and all. So when it comes to images, sometimes you have to process only metadata. Sometimes you have to process the actual image. So when it comes to images, it's a lot more complicated, and I'm not 100% sure about how to manipulate or analyze the images. I never did that, so I don't know. But when it comes to metadata, it will typically send to you in the form of JSON, and you can run some analytics on metadata. So these are the typical data processing we will do. We will do aggregations. Aggregations in the sense sum, average, min, max, standard deviation, variance, etc. Joins, so joining multiple data sets, sorting, ranking, etc. These are categories under data processing. And then data analysis or visualization, uh, we use reporting tools to report out of it. We can use BI tools, custom visualization frameworks, or ad hoc query tools to do the visualization. Now let us understand how data integration is typically done in enterprises. I'm taking the example of EDW, Enterprise Data Warehouse. We will have typically multiple sources, disparate sources. One can be OLTP, which is nothing but relational databases. Second can be mainframe-based systems from which we need to get the data. And third can be we can get actually data from multiple external applications, right? And then you have downstream application, a downstream system to capture the data. You will have ODS, you will have target system, example EDW, and you will have ETL layer, which will get the data for you. So ODS stands for operational data store. It is the term used in the data warehousing. So when it comes to big data projects, you have to learn some of the data integration best practices. You should know what is ETL, what is ODS, what is EDW. Okay, because when it comes to implementation, most of the enterprises, they try to identify the problem which is outstanding for many years on traditional databases and try to see if it can be solved in Hadoop. If it is solved, then they will add more. Either they will use Hadoop to complement the existing systems, or if they are very happy with it, they will slowly migrate the projects from existing data warehouses into big data. Okay, but typically they will start with data warehouse use cases, which are outstanding, which are problematic for many years. Okay, so the starting point itself is a big challenge for you because it's not working in anywhere else, and you have to prove that it is working here. So that's where the challenge lies sometimes. So you have to really understand the technology, the best practices, what should be done where, and all those things, and then you can roll out into Hadoop to see if it can be fixed. So the purpose of ODS is to maintain the golden copy of your data. So if you are familiar with data modeling, okay, on OLTP based relational databases, we have relational data model where the tables will be normalized. There will be primary keys on the parent tables, then foreign keys on the child tables, and it will be relating to the parent table through a constraint, etc. Okay, when it comes to EDW, we never model using relational models or normalized models. We use something called dimensional modeling, where we have fact tables, which are typically aggregated up to certain level, and then few dimensions which will give you details about the metadata. So you need to understand these terms when you want to work on these analytics projects. So don't think that I am an application developer and I don't want to get into that. Okay, things are converging, and you have to adapt one. You, you have to add more and more to your portfolio. If you are already a proven application developer or application architect, to be hot in the market, you need to think from the enterprise perspective. Already you are covered with application development. Now you have to cover analytics part also. If you don't have analytics knowledge, then someone will else will overtake you, and you will lose out in the competition. Okay, so if you are already proven application architect, it is imperative to learn these things and understand how analytics and all those things are taken care. Then only you will be able to excel and start implementing using polyglot architectures. Okay, so you have to build those skills. I will not dilute the our actual course by getting into these things. I will just take simple examples and try to focus on the technology and programming aspects of it. But once you get a chance to work in the project, you have to spend enough time to understand these technologies. What is dimension? What is fact? What is dimensional modeling? What is star schema? What is snowflake schema? What is Kimball methodology, Inmon methodology? And these things you should know. And for application developer, learning data housing is not a big deal. But it's not the case other way around. For data warehouse guys, if they have to become an application developer, they will go mad. Okay, so already as an application developer, you would have seen tens of frameworks, tens of technologies. Uh, you will be knowledgeable in shell scripting, many things, right? So learning one more thing is not a big deal. Whereas data warehouse guys, it's very challenge for them to add these application developer skills. Okay, so now we have to get data from all these different sources into ODS will maintain the golden copy of your data which is being stored in the EW. As I have mentioned to you earlier, OLTP will have a normalized data model, EW will have a dimensional model. If I want to troubleshoot if my report is correct or not, it is not practical to go to the OLTP system or closed mainframe system or XML external apps to validate whether my report is correct or not. We need to have a database which will have the golden copy of our source data, and that is ODS. ODS is used for other purposes also, but one of the purpose which is relevant for all the cases is it will have the golden copy of your source data. So if you have to troubleshoot your report, which is being generated from dimensional model, you just have to go to ODS and check, run some queries around it, and you will be able to troubleshoot. So data integration layer will liaise between all these systems. Most of the data will go through ODS and then come to EW. So when it goes to ODS from source systems, there won't be many transformations that will be running. But from ODS to EW, you have to do a lot of ETL. That's where Informatica, data stage, all these technologies comes into picture. Sometimes we bypass ODS. For example, if we just want to do a POC, we don't need to go through ODS. So that's why there is a direct path to EW also from source systems.
Durga, this is Raju. Sorry to disturb you.
Yes.
Can we have an example of how this data integration when we skip ODS or when we skip something else like that?
Yes, simple. If you are just doing POC to see whether the reporting works or not, for that POC purpose, you can bypass ODS. ODS is primarily for compliance purposes and also for as I have mentioned to you earlier, to have the golden copy of your source data so that in case of any issues with report, you can troubleshoot. It will come handy for testing purpose and all those things. I will elaborate on compliance purpose. For example, SEC, I forgot, Security Exchange Commission or something. It is in US. They monitor all the publicly listed companies, and all these companies has to be compliant with them. And they store a lot of data up to 7 years to make sure whatever these companies are claiming is true. Okay, in that scenario, they use something similar to ODS, where they get the raw data and store with them. And if someone want to file litigation against other person, then they can file. SEC can get the information from the data, validate from the data, and see if the litigation is valid or not. So for compliance purposes, also ODS will be used. And for when it can be bypassed, for POCs, ODS is not required. Only when you actually roll it out as a project, then you need to include ODS so that you can have golden copy of the data. Okay.
Yeah.
And
Thanks.
So all the data that's happening for the reporting side, is it not fetched from ODS or DSOs?
so sometimes you can report directly from ODS also. ODS also have the data. And I will give an example. I used to work for a company called ERCOT, who used to run power grid for Texas in US. So we actually used to use ODS more than EW. So what this guy ERCOT is a liaison between all the stakeholders in the energy industry, starting from generation company to transmission company to distribution company to the household. Every transaction from any stakeholder in the market has to go through them. Okay. So at times, generation company will file a litigation against transmission company, or transmission company will file a litigation against generation company. So we used to get all the transactional data and store it in ODS with audit trail. So if there is a transaction happened, or if in a workflow, something will be starting as new, and then it will go to processing, it will be updated, it will be closed or completed and then closed. 5-6 states will be there. One record will be updated 5-6 times. Okay. For keeping audit trail purposes and to close the litigations, we need to have this audit trail many times. So even though there is only one record on a source after it is closed on the target, you have to convert each of those updates into insert. And we have implemented that as part of the ODS, and we used ODS for litigations, reporting purposes. So there is certain data which we have to push to all the stakeholders as public. Okay, we have to give the link in the website for some of the reports. All these things are reported from ODS itself. EW comes into picture only if we want to provide reports for the executive management. Okay, when executive management are not in picture, then EW is optional. There are many projects which only have ODS but not EW.
So how frequently this ODS will be updated?
ODS, so all the data which is going through EW has to go through ODS. Typically, if you have EW, you will have ODS also. Without ODS, what will happen? I will give an example to explain the significance of ODS. So take the example of a retail firm. Okay, you placed an order. It will be placed as new. Then you made the payment. It will be converted to processing. They get the payment. Then they will ship the product. So it will be the status will be changed to shipped. Then I receive the product, which will change it to delivered, and then eventually it will be closed or completed. It will be marked as completed. Okay. So for as an executive management, some VP want to see how a category of products are performing over a period of 10 years. Okay. So he has to get 10 years worth of data and see the report. But in your OLTP system, after 3 days or 4 days, once it is completed, you don't need to store the data for 10 years. If you keep the data forever, it will be exploded. It will be unmanageable. So there will be a purge strategy which will be deleting all the outdated data. Okay. So you will have data up to probably 1 year in OLTP, but in ODS and DW, you might have to have data up to 10 years or whatever is the SLA for the report. Okay. So that's the purpose of ODS. Whether you have data in OLTP or not, you still have to maintain the golden copy so that I can validate my report, whether it is correct or not. I don't need to go to all the source systems, just go to ODS, run some queries, and I can validate the report. So that's the significance of ODS. Golden copy of your source data has to be stored, and the SLAs should be in line with your downstream applications of ODS. Okay, so if you are using ODS for both compliance and reporting purpose, if your reporting requirement is 10 years and compliance requirement is 7 years, and if they are using the same data for both, then you have to keep data up to 10 years. If your reporting requirement is only 5 years and compliance compliance requirement is 7 years, you have to keep data up to 7 years in ODS. So you need to decide the SLAs based on the downstream applications of the ODS. Okay.
As you said, the data
Go ahead.
as you said, the data needs to go through the ODS in the live stream. So, so that means ODS will be updated in a lively manner, right?
It depends. It can be updated in real time, or it can be updated in batches. So there are tools like Golden Gate, SharePlex, where they can read data from redo logs of the database, and we can actually update in real time in ODS. So now in the ERCOT project, we did the same thing. We actually use something called Golden Gate. We got the data from databases in real time, and ODS is updated as the transaction happen on the source. Okay, and then ETL is depending upon the project requirement. The processing happens once in 8 hours, 16 hours, 24 hours. It depends upon the SLAs. But if you don't have technologies like Golden Gate, SharePlex, etc., you might have to do batch loads. But whatever has to go through EW, typically for all the projects which are live, has to go through ODS. Otherwise, you will not be able to troubleshoot the issues of your reports.
So while in the process of real time, will there be any select commands executed? Because
No.
since there will be 10 years of data lying on the ODS, if we have a select query, then it takes longer time, and hence the transaction impacted.
So here, when I say there are three things. One is source, one is ODS, and one is EW. Okay. From the source system, you should avoid running select queries when except for the off hours. Off hours, if you need some things, you can do it, but otherwise you should not run any heavyweight queries on the source system. So from source to ODS, you can either use real-time data integration where there won't be select queries, or lightweight batch loads. Okay. Once you have data in ODS, you have to have a ETL project which will extract data from the source from ODS, and then do the aggregation and load into EW. So you will not be touching all the 10 years worth of data every day. Okay, let's say I want to see the trend for past 10 years. I just had to process 1 more year's worth of data if I already have 9 years worth of data. Okay, there is something called aggregated tables and all. Those aggregated tables will already have processed data. You should not reprocess everything unless it is necessary. Okay, and there are scenarios, what you have explained, especially in EW, sometimes in ODS. Sometimes, for example, I want to get unique visitors for a period of 1 year. I have to process the entire 1 year worth of data. I cannot count unique visitors of individual months to get the unique visitors of entire year. It will not yield me the correct results. What I have to do, I have to again process the entire 1 year worth of data to get the unique visitors. In those scenarios, yes, there will be some performance implications. There also, there are some algorithms where there will be some standard deviation or variance. And if it is in acceptable level, you can sample the data and you can get the results as fast as possible. So we need to take it case by case basis. Typically, we don't run heavyweight queries that frequently to process all 10 years worth of data every time. If we have all the old data will be recycled at any point in time. There will be 10 years worth of data. If there is a new month, only we have to touch that 1 month data and do the necessary aggregation and store it in a separate table from where reporting can be done easily. But there are exceptions to that. As I mentioned to you, unique visitors and all, there are exceptions. You have to process the entire data set. And at that time, yes, you will run into some performance issues. You have to come up with a some workaround for those type of problems. Okay, and then you have reporting layer. So you will get data from ODS or EW to reporting, and reporting can be done. Again, sometimes we can bypass EW, directly connect to Cognos business objects or any other reporting tool to ODS and generate reports out of it. Especially for ad hoc reporting and all, if the data is not available in EW, we provide data from ODS directly to the data analysts or business analysts, and they run some queries to make some decisions. It is also quite common that EDW is bypassed for some reports. So this is the current architecture. Means more details about this. When it comes to data integration, sources are disparate. We get data in real time as well as batch. The uses of ODS is compliance, data lineage, reports, etc. Enterprise data warehouse, typically source is ODS. Sometimes we will get directly data from the sources. And then we use ETL tools such as Informatica, Amnistio, Talent, etc. And for reporting or visualization, typically we do compliance related reporting out of ODS. And then actual enterprise reports from enterprise data warehouse, we use tools like Cognos Business Objects, MicroStrategy, Tableau, etc. Now we will see how this can be done using big data ecosystem. So first we'll talk about data ingestion. We can get data using Scoop from relational databases to Hadoop, but you will this is not applicable all the time. Even though you are getting data from relational databases, we might not have to. We should not use Scoop sometimes. I will explain when we actually get into the Scoop in detail. Then Flume or Kafka to get data from streaming logs. If some processing need to be done, data is processed through streaming technologies such as Flink and Storm. So as part of the data ingestion, before loading into a sink, if you want to do any analytics on the small batches, okay, then you can use technologies like Flink, Storm, and also Spark streaming. Okay. Typically for data ingestion perspective, I will give some use case here. Take the example of Flipkart. Okay. So whenever someone buys the product, typically the data will go into the relational database. And if you want to get data for completed transactions, where the purchases are done, you can connect to the source database and you can get the data and load into downstream applications. But there can be 100 visitors, out of which only 10 or 15 might be buying. 85 other visitors might come here, check the price, and go to some other website and see if there are any websites which are selling for cheaper. And if he do not find in anywhere else, probably he might come back to Flipkart and then he might do the purchase. Like that, there are so many people where a visit need not end up in a transaction. Okay, so if we start storing all this information, visitor information into database, your database will again explode. It cannot support because database call is the costliest call compared to any other thing as part of the application design. Okay, for that reason, what we have to do as part of the logs, you should start logging this information. So instead of going to the database, we will go to the logs and we will get we will apply certain rules on the logs. We will keep on polling the logs every 1 second, 2 seconds, whatever time frame it is. Identify the changes in the log and see if there is any relevant information from the visitors that needs to be stored downstream. In that is called as streaming logs. And if we have to get data from streaming logs, we have to use technologies like Flume, Kafka, etc. Okay, for relational databases, we have to use Scoop. For streaming logs, we have to use tools like Flume or Kafka. While getting data from these streaming logs, if we want to do some processing, additional processing, we can use these additional tools called Flink and Storm before loading the data.
If it's a flat file, how like load scripts, we will be having load scripts in other databases. How do we get data into?
Yeah, so load scripts and all, there is a HDFS based commands which you can use. So you have to load files into a file server, and that file server needs to be mounted on the gateway node of the cluster. And from the gateway node, either you can use Hadoop FS commands embedded as part of a shell program, or a Java based program which uses HDFS APIs to load the files into HDFS. Yeah, I will add that point also to this. It's a very, very valid point. When it comes to processing, there are two types of engines. One is IO based and other one is memory based. When it comes to IO based, it's MapReduce. When it comes to memory, it is Spark. Okay, Hive is the most popular MapReduce based tool to process the data, which means you can run queries to process the data. Again, those Hive queries has to be embedded as part of some other application. It could be shell script, it could be Java program, it could be Python program, or something or the other. You cannot just run Hive query and expect that things will be taken care automatically. You have to embed as part of some programming language. Okay, so these are the two engines which we will use for processing the data, MapReduce and Spark. We will see disadvantage of MapReduce and why Spark with new programming languages such as Scala and Spark is gaining momentum a little bit later.
MapReduce means while transferring data from source to Hadoop.
No, MapReduce is just a processing engine. Okay, so there are again, MapReduce is kind of a kernel in distributed computing. On top of this kernel, there are some wrapper tools such as Hive, Scoop, etc. And each tool does different things. So Scoop is primarily used to connect to the source database and get the data. And internally, it uses MapReduce. So when you run a Scoop command, it will be compiled into a MapReduce program. And that MapReduce program will connect to the source database using JDBC, pull the data and store into HDFS. Hive is on the other way, on the other side. Hive, once you get data into HDFS, if you want to process the data and store the results somewhere, then for processing you can use Hive, and the output of that you can store into some other database either by using Scoop or some other mechanism. So MapReduce or Spark both are processing engines. They are not primarily data ingestion tools. They are primarily processing engines. Okay, so they should be primarily used to aggregate the data, join the data sets, create the graphs out of the data, applying machine learning algorithms. Okay, so if you think about Amazon or Flipkart, you get all the transactional data and visitor data. Okay, as part of the visitor, let's say as a visitor, I went into Flipkart and I chose Samsung TV, 55-inch TV, and I chose Bose sound system and see the price, and I decided to not to buy and move back. Like that, everyone try to use the similar combination. So in future, what they will do is, if a lot of guys are doing the same thing to convert those visits into orders, he can club those two things and give a special discount. Okay, so to get up to that point, he has to process the data which is earlier which is generated earlier as part of our visits, right? When he processes that data, then only he can come to the conclusion that okay, a lot of guys are actually searching in the combination of Spark, Samsung 55 TV and Bose system, and let's give a discount on top of it, right? So for that processing, we use MapReduce and Spark. To get the data into the system, we use Scoop if it is relational database. We use Flume or Kafka if it is web server logs.
That means it is a MapReduce like a group by function.
We will see that. Don't worry too much about what is map.
Actually, in MongoDB and we already use that MapReduce by.
Yeah. So we will see that. We will from tomorrow we'll start with Scala, and probably next week I will first explain what is MapReduce as a concept and how it can be implemented in Spark and all those things. We will see that. For now, just keep it as data processing. MapReduce is primarily for data processing. So disadvantages of MapReduce: they are primarily designed for batch, not meant for interactive and ad hoc reporting. So you have Hive. Hive have something called Hive server. Using that Hive server, you can actually connect tools like Tableau and generate reports out of Hive database. But the performance will be very, very poor. Okay, because the Hive query uses MapReduce. MapReduce, even if you have one record in that table, to generate report out of that one record will take 15 to 30 seconds. Now they have fine-tuned a little bit, but still it takes a lot of time even while dealing with very smaller amount of data. So MapReduce is primarily not meant for interactive and ad hoc reporting. It's primarily meant for huge batches. IO bound and processing of micro batches can be an issue. When I say IO bound, it uses a lot of IO internally. We will see that later when we get into the details. And processing of micro batches means, let's say you have data set which is 100 GB in size and which have 3 years worth of data. Means every year for that data set is approximately 33 GB. Okay. 100 GB is a big data set. Even if you take 1 terabyte as size, over a period of 3 months, let's say it will be 333 GB, which means per day it will be 1 GB. Okay. And processing that 1 GB data, if it has to be done in micro batches, again, if you break into 24 hours, okay, or go to the minute level. When it comes to weblogs, you will get few megabytes to few gigabytes of data. Using these MapReduce based solutions to process those small batches in very short period of time is not possible. With only one or two projects, it might work fine, but as more and more projects are rolled into that cluster, it will not scale. It is very poor in dealing with the micro batches processing. Too many tools or technologies. So you have MapReduce, you have Hive, you have Pig, you have Scoop, you have Flume, etc. And MapReduce is primarily Java-based development. If you want to use MapReduce for everything, it will take forever to do the development. Just to do the word count, you will write 40-50 lines of code. And then if you want to join two datasets, if you want to implement it in MapReduce, it is not practical. You will end up spending writing thousands of lines of code. Still, there will be some gaps which you might not have think about, and there will be bugs.
Flume is also using MapReduce program?
No, Flume does not use MapReduce. No, but in the Hadoop ecosystem, there are so many tools: MapReduce, Hive, Pig, Scoop, Flume, etc. Even though Flume does not use MapReduce, it is categorized under Hadoop ecosystem. Okay, probably I should remove Flume from here. Yeah, Flume is not MapReduce based tool. But what I'm trying to, the main point is there are too many technologies, and coordinating with all these technologies is a nightmare. For example, You have a relational database, and per day you are trying to get 10 GB worth of data, and you have to use Scoop to get the data. And Scoop is just a bunch of commands. Okay, and using those commands, you cannot build an application. If you want to build an application, you have to use some programming language. Either you have to develop Java based or shell scripting based or something. So that module itself has to run independently to get the 10 GB data every day into the system. And then you use Hive queries. Hive queries cannot are nothing but SQL. And if you have to write a operational application, again you have to use some other programming language. So there is a lot of learning curve, and it takes a lot of time to develop even a simple projects using these many technologies. Okay, not suitable for enterprise hardware where storage is typically network mounted. As I have mentioned to you earlier, if it is network mounted, your network can become a bottleneck, and because it uses a lot of I/O and a lot of network, it is not suitable for enterprise hardware. So that's where Spark can solve many issues. Spark can work with any file system, including HDFS. Processing is done in memory, hence I/O is minimized. Suitable for ad hoc or interactive querying or reporting. Streaming jobs can be done much faster than MapReduce. Application can be developed using Scala or Python or Java. You can choose your programming language, and if you want to connect to the source database and want to get the data, there is Spark JDBC. You don't need to use Scoop. You just register the source database drivers, and then use JDBC from Spark directly, get the data, and continue processing using Scala or Python. You don't need to use multiple technologies to develop end-to-end application. So similarly, the case with Hive, you can actually run Hive queries directly from Scala. Okay, let's say you want to get data from a source database and get data from Hive, and do additional processing, and then store the output somewhere else. With the Hadoop-based technologies, you have to have one application, one module with Scoop, one module with Hive, and another module to write to the third database. And we have to integrate all these things. For that, we might have to use Woozy or some other workflow tool. Whereas with the Spark, you will have fewer moving parts, and they can be integrated with one programming language of your choice. You can use Spark JDBC to connect to the source system and create RDD out of it. You can issue Hive queries from Spark directly, and you can do additional processing on top of these things using Scala or Python as programming languages with Spark APIs, and you can proceed further. So compared to MapReduce based applications, there will be fewer moving parts, and your application development will be much faster. Okay, so that's why Spark is pushed so hard by Cloudera. They just announced it in August that they will be dumping Java MapReduce, August 2016, and by December they have started Cloudera certification with Spark, and they removed one of the most successful certification they have, which is Cloudera certified developer of Apache Hadoop, which is based on MapReduce, and now they are only talking about Spark wherever they go. Okay, so they realize the potential of Spark and the challenges they have with respect to MapReduce based application. That's why Spark is getting a lot of momentum. Now Hortonworks also pushing Spark quite aggressively. Mapr is another major vendor of big data. They are also pushing Spark quite aggressively. Okay, and compared to Java, Scala and Python are functional programming languages. You can write minimal code to do a lot of stuff. With a lot of complexities are hidden for you. There is an initial learning curve. It will take time to get expertise in these programming languages, but once you learn it, especially from the data processing perspective, they are much simpler than Java. So this is how it will look like with big data ecosystem. Okay, so if you see, the source systems will not change. In the middle, the enterprise data warehouse, we have homogeneous servers now. Earlier, we have ODS which look differently, enterprise data warehouse which look differently, and data integration layer which look differently, which means ODS can be a traditional RDBMS, enterprise data warehouse has to be Teradata appliance or Greenplum appliance or something, and data integration layer could be Informatica, data stage, etc. So you have to have heterogeneous hardware to support. Whereas here, you choose homogeneous hardware and set up everything on it. You will have both ODS as well as EDW as part of your Hadoop cluster itself. ETL also will be done on directly on the cluster instead of doing using Informatica. We will be doing we will be performing ETL using um, uh, Hadoop based tools. Even Informatica Big Data Connector, they give two options. One, you can use Informatica server to process the data, or you can use Hadoop cluster to process the data. And irony is, if you want to use just Big Data Connector, you have to pay licensing for the Informatica server also. Okay, so you will end up paying for Informatica server to get Big Data Connector. And once you get the Big Data Connector, when you submit the job, it will not run in using native Informatica code. It will run using Hive. Okay, so you have Power Designer in Informatica where you will design the mapping, and when you submit the mapping, the workflow will be executed as Hive queries in the uh, Hadoop cluster, in the big data cluster. If there is an issue with Hive query, Informatica cannot do anything. So you are not getting support, proper support. So that's where a lot of companies are not buying the license of big data connectors of Informatica, Talend, Pentaho, etc. Talend and Pentaho get some success because they are a lot cheaper than Informatica. But Informatica is struggling to make a mark in big data market because in general the trend is against licensed products, and they are actually selling with premium when it comes to big data connectors. That's why there are not many buyers, and also they don't have expertise they don't have Hadoop expertise in their organization, so support also will be very sloppy. So the reporting layer, so you can have an optional reporting database, but this reporting database will be very lightweight compared to EDW. You don't need to have a Teradata type of appliance. All the raw data and the data with lower granularity will be stored in Hadoop layer. Only data that needs for reporting purposes will be stored in reporting database. So only fraction of data will be there in reporting database to serve your reporting layer. The reason why we used to have the separate reporting database is, as I have mentioned to you earlier, before Spark, reporting out of Hadoop um, uh, is not interactive in nature. It takes a lot of time to get reports. Now with Spark, the relevance of that reporting database is going down significantly. A lot of guys are using Spark connector or Impala connector of Cloudera to directly report out of big data clusters. But still, some companies are using traditional databases for reporting purposes because they work well with business objects, MicroStrategy, etc. And uh, because the BI tool will come with many features like role-based authentication and all those things. Still, they are using, but eventually the relevance of that reporting database also will go down significantly. Okay, we are very close towards the end. So let us map the tools. So these are the core components of Hadoop: distributed file system, and then MapReduce as well as non-MapReduce based tools. Okay. And as part of Hadoop ecosystem or big data ecosystem, we have MapReduce based tools: Hive, Oozie, Pig, Mahout, Scoop. All these are MapReduce based tools. So Scoop is just a export import utility. Hive is SQL. Pig is alternative to SQL. Some people uh, are averse towards SQL. They feel that SQL is inferior and it's not meant for solid programmers. So there is a bunch of people in Bay Area who think that people who are using SQL are inferior. Okay, for those people, they have developed Pig. Okay, and most of the things which can be done using Pig can be done with Hive. Now Pig will cease to exist very soon because of Spark. The syntax of Pig is similar to Scala, Python, etc. So it doesn't make any sense to use Pig anymore. So Pig will cease to exist very soon. It will be written off probably in next 2-3 years. Oozie is a MapReduce based workflow tool. Okay, and Mahout is a machine learning libraries. All these are MapReduce based. And then ad hoc querying tools, there is Impala, Presto, so that we can actually get queries written a little bit faster. The reason why I mapped it to non-MapReduce is, so when it comes to MapReduce based tools, these tools will not have anything related to Hive or Scoop on the cluster. They use MapReduce for processing and HDFS for file system. Whereas Impala, if you want to run Impala query on the cluster, you need to set up something called Impala D on the cluster. On top of existing components, each of the nodes has to have additional process. Because of that only, it can actually run in ad hoc fashion. It is bypassing MapReduce and it is using its own architecture. And then NoSQL, okay, this is wrong. There it should have HBase. Yeah, HBase, Mongo, etc. In-memory processing, Spark, and then data ingestion tools, Kafka, Flume. These are all non-MapReduce based ingestion tools. Sometimes if you want to do any analytics while ingesting the data, you can use Storm or Flink. Okay. Why? Okay, this you can ignore. So now comes installation. We can use plain vanilla Hadoop, but installation is very tedious and error prone, and we need to integrate with monitoring tools. That's where distributions comes into picture. They make installation or upgrades easier, better monitoring, easier maintenance, and many more. We have Cloudera, Hortonworks, Mapper, AWS EMR, IBM Big Insights. These are the distributions we have. Out of these also, Cloudera comes with something called Cloudera Manager, which will manage all these tools. They provide wizards to set up the cluster. They provide alerting notifications mechanism, etc. Hortonworks is also same thing. The Cloudera and Hortonworks are purely competitors. And then Mapper, the only difference between Mapper and other two is Mapper have their proprietary file system, which is different from HDFS. Apart from that, rest of the stuff is same. And AWS is cloud-based, and we need to use pay-as-you-go model to get benefits out of AWS. And it is also quite extensively used. So that's it. Those are the distributions we have. And other distributions such as IBM Big Insights, Oracle Big Data Appliance, all these use either Hortonworks or Cloudera. IBM Big Insights use Hortonworks. Pivotal Hadoop distribution uses Hortonworks. And Cloudera's Big Data Appliance, Oracle's Big Data Appliance uses Cloudera internally. So only these distributions are you need to worry about. You don't need to worry about any other distributions. Okay, only these 4 distributions you need to worry about. AWS is quite popular in startups where they don't need to invest a lot of money on infrastructure, and the benefits are enormous. Means I worked on a project with a company called Harman, where we actually process almost tens of gigabytes of data for $2,000 per month. If we have to have a cluster for that, our cost will be at least 20-30 times to that. So AWS is very, very powerful. I know a company called Welltie. They actually spend $100,000 per year for AWS, and they claim that if they have to build data center, they have to invest at least $5 million, and they're just using AWS and spending $100,000 for their data processing needs. So AWS is very, very powerful. AWS, Redshift, and all these are all MPP cloud-based technologies, and they are getting a lot of traction. Okay, so this is about distributions. Now let us see our cluster and what we have, so that you understand a little bit about the mapping. So these are called as services. Okay, and each service is mapped to hosts at different level depending upon the architecture. I will cover few technologies and show how you can interpret the architecture. You see, we have HDFS, which is the foundation, then Yarn for data processing, which is nothing but MapReduce. Yarn and MapReduce 2 are related. You will understand in detail later. We have Hive, we have HBase, we have Pig, we have Scoop, we have Woozy, and then we have Kafka, we have Spark, we also have Flume. So all the technologies which I have mentioned in those slides are there. But as part of the course, I will be covering HDFS. I will be covering Yarn and MapReduce 2 from the developer perspective. Okay, and then I will be covering Hive, Scoop, Spark, and HBase. Okay, so first 3 weeks we'll be focusing on Scala, which is a programming language. First 4 sessions, probably starting from next session, 3 to 4 sessions will be only focusing on Scala. Then we'll get into Spark, and then we'll get into Hive, Scoop, HBase, etc. So the way you should interpret is you can go to hosts, and there is a naming convention to this. Okay, the first one you need to focus is on this WN. WN stands for worker nodes. On a typical production cluster, most of the servers will be worker nodes, and then there will be bunch of masters. Depending upon the architecture of the product or the service, we might have masters for some of the services. Not all services will have masters. And then typically we'll connect to the gateway node. At least we'll have 2 gateway nodes in the production cluster. But depending upon the number of projects we have, it can be more than 2 also. Typically it will be in the range of 2 to 4. Okay. The reason why we have at least 2 is for load balancing purpose and also failover purpose. For example, if the motherboard of the gateway node is gone, then the other gateway node can be used to submit the jobs. The file system has to be mounted on both, or at least when the when a server fails, whatever mount points are there on that server should be failed over to the other one, so that the jobs can be kicked off from the second node. So we can design like that in a heavy load production clusters. At least in a good design, even gateways should be at least 2. Okay, so in my cluster I have 3 worker nodes. These 3 are masters. You will understand what is NN and what is RM later. GW stands for gateway node. Now if we go to Ambari, and if you click on one of the services, HDFS, you see there are 3 data nodes. Okay, and these 3 data nodes are nothing but worker nodes, and we have NN01 and NN02 on the in the hosts. NN stands for name node. So NN01 have name node and NN02 have secondary name node. Similarly, if you go to Yarn, node managers are on all the 3 worker nodes. We can click on this and it will automatically be filtered. So even if you click on data nodes, you will get these things only. You can also actually click on these components and see what all are available on those nodes. Okay. So once you understand these services, you will be able to relate with those things easily, and you need to understand the relevance of configuration files or configuration properties and all those things, and we will see as we proceed further. Now if I click on Spark, Spark does not have anything except for Spark History Server. Okay, Spark History Server will give status of completed jobs, but for storage it uses HDFS. That's why there is no service for storage. For processing it uses Yarn. That's why there is nothing with respect to processing here. Similarly, if you go to Pig or Scoop, only client is installed on all the nodes. There is nothing, no service is running for Pig, because the architecture is its client only. It uses HDFS for file system and Yarn for processing. Similar is the case with Scoop. So we will see these technologies as we proceed further. And now let us get into the curriculum, what I will be covering. Okay, we have 2 more minutes. Probably I might extend for two more minutes. Within 4 or 5 minutes, we'll be done. So there are 2 certifications from Cloudera. One is CCA Spark and Hadoop Developer, and the other one is CCA Data Analyst. Okay, as the name suggests, CCA Data Analyst is primarily for analysts who have SQL knowledge, who work as data modelers, etc. Okay, and it primarily emphasizes on. Let me go through the certification. Okay, so let's go to the curriculum. So you can see the curriculum here. They're talking about prepare the data, provide structure to the data, and data analysis. Okay, so prepare the data. It's all about Scoop, and then transform value. Yeah, this is all about Scoop. Nothing more than Scoop. Provide structure to the data. It's primarily about DDL on the tables, how to alter the tables, how to create tables, etc. How to create partition tables, how to create views. For data analysis perspective, you just need to write SQL queries. But from the Hive perspective, it's purely on Hive and Scoop. That's it. Okay. And then if you go to CCA Data Analyst, sorry, CCA Spark and Hadoop Developer. So they're talking about data ingest, which is nothing but Scoop and Flume. They also cover Flume in this. Flume is not covered as part of the data analyst certification. As part of transform, stage, and store, we primarily talk about loading data back and forth using Spark, and then joining between HDFS and Spark, and then joining the data sets, calculating aggregates, and then filtering the data, and then sorting and ranking of the data. Simple transformations you need to know using Spark. This is purely Spark, and this is very, very important if you want to give the certification. I have to iterate this, even though Vinil mentioned that certification is not that important. I have people from other company called Epsilon, and they are primarily taking this course for certification purpose. So this statement is very, very important. They are saying, see note above on exam question format for more information on using either Scala or Python. So if we go up here, they are mentioning about exam question format. So what they are saying is, they will give particular scenario and you have to solve it. Sometimes you just have to use Hive or Impala to run the query and solve the problem. In some cases, coding is required. In order to speed up development time of Spark questions, a template is often provided. Means sometimes they might give templates, and you just have to fill in the templates and submit the code, and you are done with it. But they mentioned often. They are not saying that it will be provided always. Okay, so when it is not provided always, or even when templates are provided, you can choose the programming language of your choice. It could be Scala or Python, and you can use one programming language to solve all the problems. If they give templates, they give templates, 2 templates for Scala, 2 templates for Python. Okay, so if they don't give template, or even if you don't want to use template, then you can use the programming language of your choice. So I will be primarily emphasizing on Scala, so I will recommend you to go with Scala and solve all the questions using Scala. You are not required to use the template, and yeah, this is what I have explained. And then when it comes to data analysis, it's primarily DDL to create tables in Hive. They don't ask any SQL, complex SQL or Hive queries as part of this exam. Okay, by clubbing these two and covering the curriculum of these 2 courses, I'll be covering Hive completely, because Hive is required for CCA Data Analyst and Spark is required for CCA Spark and Hadoop Developer. And then there is a common curriculum between the 2, which is Scoop. So we'll be covering multiple technologies in depth while covering these two certifications. Why I choose certifications? Not that to market these certifications. What I felt over a period of time is without proper scope, you will be pulled into all the directions. I know a lot of people who started learning MapReduce with me without going through the certifications. They dropped in the middle because by the time they learn MapReduce, they started hearing about Spark, everywhere Spark. And now people started hearing about Flink. They think Flink will replace Spark. No, Flink is only for streaming analytics, like Storm. Storm, Flink, and Spark streaming will compete in one area, but Flink will not be replacing Spark completely. And also, even the Java MapReduce is not highly relevant. People who spend enough time on Java MapReduce will always have an edge because they know internals about how it works. Even though they give up Java MapReduce now and work on Spark, they will do better job compared to people who didn't learn at that time. Okay, so this will give you a focused scope, narrowed scope, and focused scope, and you will sit and learn few technologies. It will act like a foundation going forward. Whether you give the certification or not, it's secondary. But at least prepare from the certification perspective so that you define the scope and learn something by following that. These are not trivial technologies which can be replaced on day-to-day basis. Even though Java MapReduce is less relevant now, still there are some projects where it has to be used, and and those concepts are applicable everywhere. Even MongoDB, you have MapReduce, so the concepts does not change. MapReduce concepts still remain intact. If you would have learned MapReduce 3-4 years back, the concepts will you will digest the concepts better, and you can learn any technology very quickly now, wherever MapReduce is involved. Okay, so for that reason, learning from the certification perspective gives you different perspective, and there will be a goal for you, and you will learn over a period of time. After 3-4 months, you will feel that you have learned something. Okay. On top of these two certifications, I am also covering HDP-CD Spark. Okay, and if you go to the curriculum, and if you go click on view exam objectives, there is Core Spark and Spark SQL. Spark SQL is not part of CCA, and for the project's perspective, Spark SQL is very important. So I will be covering Spark SQL also as part of this course. So you can give CCA data analyst. Probably most of your developers, probably it might not be a good certification to have. I will recommend either to go for with the CCA Spark and Hadoop developer, or HDP-CD Spark if you are interested to give the certification. Between these two, I will generally recommend CCA Spark and Hadoop developer because it have multiple skills in that, whereas HDP-CD Spark only have one thing. So you should think from the big data perspective rather than Spark perspective. If you think from the big data perspective, CCA covers a lot more, and you will feel a lot more confidence if you prepare for CCA certification and finish it off. If you are already certified on one or two certifications in the past, and if you want to add new certification to your portfolio, probably you can consider HDP-CD Spark. Okay. So that being said, that's it. If you have any questions, I can take it for a couple of minutes. Otherwise, we'll wrap up. Anyone from Epsilon have any questions? Okay, so so tomorrow, what you have to do, make sure you set up Eclipse with Maven plugin and Scala IDE. If you need instructions, I have that on my blog. I have only for Eclipse with Maven. Yeah. So if you go here, Big Data Engineer, what you have to do is in the Java MapReduce overview, here I covered about setting up Eclipse with Maven. You have to go through this link. Once that is done, okay, then you have to go to Apache Spark with Scala, and you have to go through setup Scala and SBT, setup Scala ID for Eclipse. Yeah, these two things you need to follow. So you have to go through setup environment Eclipse with Maven, setup Scala and SBT, and setup Scala ID for Eclipse. These three topics you have to cover. You have to use if you want to integrate Scala as part of your Eclipse with Maven plugin. Otherwise, you can set up using IntelliJ. I don't have content, but it's pretty straightforward. You just have to say Scala install, go here, and when you set up using 2.11.8. Go to all downloads, choose Scala 2.11.8, and here you can see IntelliJ IDEA with the Scala plugin. You can click on it and download it and install it. Okay.
Not the latest one.
Don't use 2.12.1. There are some issues with that. Okay, so we will be doing. We have to use SBT. Even though you are good in Maven, don't use Maven because Scala works well with SBT. So you have to learn how to do it with SBT. Not for the certification perspective, but from the project's perspective. Okay. Okay, then that being said, thank you very much. We will catch up tomorrow.